end behavior of rational functions. The question is h of x is equal to 5x to the fifth minus 9 all over 9x to the fifth minus 5. Find the horizontal asymptote of h. So I have the question written down. First off, let's talk about what an asymptote is. Okay, there's two types of there's many types of asymptotes, but there's two main types that you're going to be working with probably in this class. There's a horizontal asymptote. Remember, horizontal is this direction. And we also have vertical asymptotes, which is this direction. You can also have diagonal asymptotes, but that's not until pre-calculus, I believe, so you should be okay without knowing that right now. So a horizontal asymptote is this green one, which is what we're focused on here. And on some questions, like this one up here, or some equations, there will be a horizontal asymptote. Not all of them have it, but some do. And what that is we could have a graph. Let's say it starts way out here, okay? So coming this way, and we're going to hitch a little bit, and then go back this way. Now, let's label this. We have 1, and this is going to be 2, okay? 1, 2, 3. So at 2 is our horizontal asymptote. What that means is that our graph will always get closer and closer and closer to it as x approaches positive infinity, but it will never ever cross over that line. So that means that we have a horizontal asymptote at 2 in this question, or this potential graph. Our question is something completely different. The way you find it without having a graph and only having the equation in front of you is you take the numerator and denominator and you look at the leading term. And the leading term is always the term that has the biggest exponent. So x to the 5, x to the 5. And you isolate those. So 5x to the fifth over 9x to the fifth. All right? You ignore everything else in the problem. There could be 4 other terms up here. You ignore everything else. And what you do is you simplify it. Well, x to the fifth over x to the fifth is just simply canceled out. So those go away. And we're left with 5 over 9. And that is your horizontal asymptote. It's 5 over 9. I also graphed this so you can see what it would look like on a graph. So 5x to the fifth minus 9, 9x to the fifth minus 5. And you can see here that our 2 is here, our 1 is here, half is here. You know 5 over 9 is just over halfway. So it looks like the answer is correct. And we can go out here and click on it, and you can see our value for y is 0.556. Well, if you don't know what 5 over 9 is, you can pull a calculator out. 5 divided by 9 is 0.555556. So it's repeating. So decimals is simply rounding up at 0.556. And we go to the negative side and see what's happening over here. Okay, so it's coming from here, this way it's going to positive infinity and approaching 5/9. And from here it's going to negative infinity and also approaching 5/9. So our answer for the first question would be 5/9. Okay, next question. P of x is equal to 6x minus 12x to the 9 over 3x cubed plus 7. Find the horizontal asymptote of P. All right, so we have our equation written. And once again, we're going to do the same thing as last time. Isolate the leading term, which this has 6x first and 12x second. This is actually our leading term in standard form. That has the highest exponent. This exponent is 1. That's 9. So that's the bigger one. And 3x to the 3. So, once again, we're going to isolate those and then simplify and see what we have left over. All right, so we have x to the 9, x to the 3, negative 12 and 3. So the negative 12 and 3 will simplify to negative 4. X to the 9 could be rewritten as x to the 6 times x to the 3 over x to the 3. What cancels out? X to the 3's. What's left over is x to the 6. So last time we had 5 over 9 left over with no variables. When you have a variable, this means that there's actually no variable in the numerator, which is what we have here. This means that there's no horizontal asymptote. As x goes to infinity, so will y. So not every single graph, or actually function, and I have it graphed here, will have a horizontal asymptote. And you can see here, if we zoom out, there's no line horizontally that our graph will not cross. It just goes on forever, up and down. I'm doing that pretty far, and you can go way further out, but it's going forever both directions. So the answer here is this graph of P does not have a horizontal asymptote. Okay, and that's the case every single time that your numerator is bigger than your denominator in the exponent. So if it's x to the 4 over x to the 3, you would still not have a horizontal asymptote. We can change that in here too if you want. Let's just see what it looks like. It'll probably just, it's not going to escalate or go up as far or as fast. So yeah, I created a different kind of graph. It's going to approach here. So this is a different type of situation. This doesn't get closer and closer and never touches it. It just gets here and bounces back away. So this is going to be a vertex here, not an actual asymptote. And if we go to 3, we'll have an asymptote at, should be -4. Because -12 over 3 would be -4. And here we go, -4, 3.999999. And going this way, 3.99999, just negative. So -4 will be the horizontal asymptote here. Next question. Question 3. Q of x is equal to 6x to the 5th minus 2 all over 3x squared plus x to the 9th. Find the horizontal asymptote of Q. So I have that problem written down right here. Q of x is equal to 6x to the 5th minus 2 over 3x squared plus x 9. So once again, we're going to isolate the leading term. X to the 9 is the denominator, and 6x to the 5 is the numerator. So move that over, or x to the 9. So first thing you can notice is that our denominator has way more x's. So when we simplify this, we're going to end up with 6 over x to the 4. Every single time that the denominator is the bigger one, your horizontal asymptote is going to be approaching 0. So remember, if the numerator is bigger, then it's going to approach, you won't have one. If the denominator is bigger, it's 0. If they are the same, it's going to be the ratio, just the number that's left over when you simplify. I also graphed this function right here, and you can see it goes left and right. Now it does cross right here. So it can cross at a point and also have a horizontal asymptote somewhere else. So that could be a little confusing at times, but so you can see over here how it just gets closer and closer to 0, but never ever. Well, I guess here it got to 0, but that's just because it's rounding. It's actually not. Yeah, see, if you get closer, it's not actually at 0. It's just rounded to 0. So our answer to this question would be 0. All right, g of x is equal to 2x to the 8th plus 3x cubed plus 5 all over x cubed minus x to the 8th. All right, so this question is a little bit different. It's asking, what does g of x approach as x approaches negative infinity? So as x gets bigger and bigger, but in the negative realm, going like -1,000, -100,000, -1,000,000, -1 billion, and so on, what is happening to y? So you could put in those numbers and figure out what's happening to it. Or we could also look at the leading coefficients first. So we have it written right here. We have 2x to the 8th plus 3x cubed plus 5 all over x cubed minus 8x to the 8. Isolate your leading terms. So actually should be negative. Okay, so we rewrite it. 2x to the 8 all over negative x to the 8. So we simplify, and we end up with these canceling out. We have 2 over -1, which is equal to -2. So we got a horizontal asymptote of -2. Now, remember what the horizontal asymptote actually means. It means that as our graph gets larger and larger in either direction, so if it's going, let's say, this way, it's never going to cross over -2. So it's -1, -2. So it never will cross over that line. Well, the same case goes for negative infinity, which is what we're concerned about in this problem. So as we get closer and closer to negative infinity, which is never possible, you're going to get closer and closer to -2 and never ever cross it. So looking at these answers, I went to the answers. Looking at these answers, I think Con actually made a mistake. I graphed it as well, so they have 2 here. This should be -2. If you look at the graph right here, here's the graph of that function, and you can see that there's a horizontal asymptote at -2, and they have it listed as +2. They do make a mistake once in a while, so I'm going to make that assumption. Did it again here. Interesting. Oh, there's -2. I didn't even see it down there. Huh. All right, so I was right. There it is. And there we go. All right, and we're done.